Hello everyone. So welcome back to the next lecture of this course on climate change and the path to net zero emissions. What we looked last time was basically the whole issue on the climate change, and basically we started understanding that what is atmosphere, why atmosphere leads to a kind of a stable temperature on the earth's surface. We also looked into that there are some gases which are responsible for that temperature to be stable on the earth's surface, and what we started looking into phenomena was that we started looking into phenomena like global warming and climate change, that we started understanding that there are long term changes which is happening on the global temperature surfaces, which is primarily a derivative of climate changes. And where we ended last time was understanding high level issues which are a kind of a sub part of climate changes, and while global warming is one of the part of that thing. So before I move forward, just to kind of talk something on the lighter side, or maybe not on so much on the lighter side, that while I'll show you all these evidences which are very clear with respect to what is happening because of climate changes, there are still non-believers in the system. So I'm not here to educate anybody on becoming a believer. What we'll talk about is in terms of pure numbers, that like numbers are telling a story. We want to believe that those story or not, and we want to put a kind of a different twist to it. All of this is up to individual. We are no one to comment on that. There are people who still say that what is if it is all a big hoax and we have created a better world for nothing. So I'm not in a position to comment on that, those kind of phenomena. I'm just here to kind of talk about science and policies and technological path to all these solutions, right? So let us move forward. So as we discussed that we will be looking into the proof of all these climate changes which is happening, and let us start looking into data, that what is leading to this belief that the climate is changing, and it is changing because of the human interventions, right? So one of the proof that we have is that number of global climatic related events or disasters which has happened over last 10 to 20 years has drastically increases. Look at the number of events which has taken place in last 10 years, and look at the frequency of those events happening year on year basis, right? So these events have kind of become almost 10 times over, more than 10 times over last 10 to 11 years, which is huge, right? And while this is happening, there are a few phenomena which are happening because of some natural occurrence earlier also, and now because of some natural occurrences. But primarily, if you look at the global map all over, it is happening because of the human influenced issues. Like so look at the number of red dots, right? So the primarily the whatever changes are happening is all happening because of the human intervention issues, like and issues which are happening in with respect to rain and flooding, happening with respect to storms, with the wildfires, compound effects. A lot of effects are happening, and which is a very clear indicative that it is human interventions are leading to many of such phenomena which is taking place. Let's start looking into all the aspects separately. So if you look into the air, what is happening is that atmospheric circulations are changing, and that circulations are changing because of the changes in temperature, changes in humidity, and changes in the weather patterns all over. Air temperatures in the lowest few kilometers are going up, and they are going up very drastically. As we saw last time that the global surface temperatures has increased as much as 1 degree centigrade, about 1.5 degree centigrade in very recent years. Water vapors in the atmosphere are increasing. Surface temperature, we already talked about it, is increasing. So very clear thing that air patterns are changing very frequently because of the circulations are changing. Those circulation changes are leading to changes in rain pattern. Water vapors are changing, which is leading to higher loading of water vapors, and which is leading to this cloud busting issues that we are seeing of late a lot. All these surface temperatures which are changing, and which is a non-uniform changes, as we will see in the data as we kind of go along, which is also leading to some different kind of weather patterns and weather changing. On the ocean side, what we are seeing is that sea levels are going up, sea surface temperature is going up, species ranges are shifting, ocean heat content is going up, ocean acidification is going up. So, overall ocean, which has been the primary source of carbon dioxide absorption on a long term basis, Earth to be stable and keeping the carbon dioxide in a check limits. Remember, while we talked about the carbon dioxide is needed for Earth to kind of keep a kind of a comfortable temperature, we also saw a phenomena on one of the planets where the carbon dioxide was 90%, it was leading to a very, very warm atmosphere. So, what it means primarily is that while we need carbon dioxide on the Earth's surface, we need it in a control limits. If those limits kind of goes up, the ecological balance of the system will start changing. And so, an ocean has been one of the primary source of this carbon dioxide absorption. And what we are seeing is that of late is that all these changes in the carbon dioxide kind of loading in the system is changing the ocean behavior a lot. So, we will look into this data more and more. On the land side, what we are seeing is that while the global greenness has increased deliberately, there are issues with respect to growing seasonal length, which is changing. The seasons are longer now and seasons are more uncontrolled seasons which are coming. And there are specific species range are shifting, species are changing from one geographical location to other geographical location, which is leading to some ecological changes and biological balance changes. Precipitation on the Earth's surface is changing, which is leading to uncontrolled rains in some areas. Some areas are feeling more drought and some areas are getting flooded. On the ice cover side, the snow cover is reducing, permafrost extent is increasing. So, more and more areas which are coming out of the Earth, which has been covered historically from the Earth's surface, and which is leading to more release of global warming gases in the atmosphere, which is even further adding to whatever emissions has been taking place by the human activities. Even humanities indirectly are influencing some of the areas to get uncovered from snow, which is leading to further releasing of these gases. Ice sheets are further decreasing, Arctic sea ice is decreasing, glaciers are decreasing. So, overall what we are seeing is that it is a cumulative effect in all aspects of our atmosphere, which is changing and which is not issues in isolation. All these issues kind of culminate and they kind of add into each other and further intensifies the issue, right. Let us now looking into all these issues one by one. So, overall the climate change evidences, if you look at it, that we have more drier than average conditions. So, if you look at the precipitation side of the whole thing, you can see some areas have become much wetter than they were in the past and some areas have become much drier, which has become in the past, right. So, it is not that amount of water vapors have reduced on the Earth's surface. What is it leading to is there are very clear indications that the weather patterns are changing, which are leading to a very different kind of a weather patterns which we have seen in the past, which are leading to then a lot of human related issues. So, if you just look at this graph carefully, so this area Southern America, some part of Northern America, some these part of Northern America, specifically on African sides, some part of Asia, they are showing much drier average behavior than earlier. Like some part of this, even this, some part of New Zealand, some part of Southeast Europe or South Asia is showing much drier pattern than it was showing before. While some other portion, like when we start looking into upper part of China, this part of Europe, some parts of India and even some parts of Africa, they are showing much wetter phenomena than earlier. Like you would have heard about this Dubai getting very uncontrolled rain a few years back, right. In India also the number of events which has occurred with respect to cloud bursting has increased a lot because of this lot of precipitation which is taking place. So, what is happening is that lot of places are showing much wetter thing and lot of have become much wetter and lot of places are becoming much drier. So, this is leading to a phenomena which is natural disasters. On the Earth temperature side also, while we talked about that the Earth temperature has kind of gone up, and as per one of the reports, the Earth temperature in 2024 was about 1.28 degrees centigrade higher compared to the average of the pre-industrial era. So, these are lines which is kind of pre-industrial era and the global temperature has kind of gone up by about 1.28 degrees centigrade in 2024. Another phenomena which you need to notice along with this is that this temperature change is also not uniform. right. So some areas has becoming much warmer. Look at this part of North America, look at this part of South Asia or Europe, or this part of Africa. So they are becoming much warmer, and look at the overall phenomena of on the North Pole side, that area is becoming, so northern side of the thing has becoming much warmer. But if you start looking at some other areas, the effect is not that much. Look at this part of India, some parts of Africa, some parts of Australia, they are not affected so much. So what it means is that while the average temperature is increasing, some parts are getting more warmer, some parts are getting less warmer. What it means in that case is then the earth airflow would be changing, because the air, as we all know, flows because of delta T, the thermal density difference, the air flows. Now, as soon as the temperature pattern starts changing, also leads to a change in the airflow of the whole system also, that will lead to the rain pattern changing also. So, that in turn will lead to some areas getting into drought and some areas getting into more rains and all those things, and what we saw in the previous slide very clearly, right. So, just to kind of reiterate on some of these aspects. So, some land areas are becoming much more warmer, they were earlier. New higher annual mean temperatures are recorded over large areas of South and Central America, east of Western Pacific. Very warm temperatures are being observed in some of these areas. Some land area outside of tropics also experiencing very exceptionally high temperature, like North America, North Africa, Europe, South and Eastern Asia, they are experiencing much higher temperature. And if you look at it, there are some areas which are actually not leading, which are now also start looking into temperature which are lower, right. So, this whole balance, ecological balance, which has led to a kind of a sustained life system over the last few centuries, is now very clearly showing that this pattern has started changing. And so if you just go back to 2 slides before, so and that is leading to all these disasters which are coming and happening much and more, because some areas are becoming much drier, some areas are becoming much wetter, and leading to the next indicator, which is the ocean side of it. If you look at the ocean heat content is changing. So, ocean has been the primary source, and we'll see in like when we look at the carbon cycle, that ocean has been the primary source of carbon sink historically, right. So, since water can absorb much more heat compared to air, because water molecule is heavier, so it means ocean could absorb much more heat compared to the atmosphere, right. So, and that is what has been the temperature control point of the earth from a historical perspective. So, but because of that, 90% of the excess heat whatever has happened over last century has been absorbed by sea. But what it has done in terms of is that the heat content of the ocean has increased a lot. So, which has led to a very high amount of energy in terms of heat energy which has been absorbed by sea. So, just look at in terms of zettajoules, the amount of heat energy which has been absorbed by sun, it is increasing year on year, and it is about 372 zettajoules of energy which has been absorbed by sea from since 1955, and which is a huge number, which is kind of leading to a lot of warm sea. Again, warm sea would mean warmer temperatures. Warmer temperature means again change in the global temperature phenomena, and again that would mean change in the weather patterns, change in the, so short term weather patterns, change in some places getting more rain, some places getting less rain, some places getting uncontrolled rains also at times, right. And this variation that you saw on top of this center line is the 2 sigma variation, and when we go into the climate change modeling or further modeling also, or you know this phenomena pretty well, that these numbers are not usually sacrosanct. There are some experimental errors or experimental variations or measurement errors around a central value. So, this broadening of this curve is primarily because of this change in this is basically a 2 sigma error this line is indicating. So, moving further, so then if you look at the ice extent, ice is getting lesser and lesser. So, this is the how many million square kilometers of the area is covered by ice, and this is taken in the month of September. September is the month when the least amount of ice takes place, because the summer gets over, and by the time the summer gets over, the September is the month where the ice content is the least, and these measurements are done around that time, and this is data by NASA. The decrease in the ice cover has been about almost 12.2% on a per decade basis over last 40-50 years, which is a huge number, right. So, what it means is multiple phenomena, like One is we will look into a effect called albedo effect, which will understand that how is that leading to the whole thing. But where is this all ice, melted ice going? So this melted ice is in turn going into sea, which is leading to another phenomena, which is leading to a phenomena where the sea levels are rising. This is leading to a phenomena that where a lot of cities, the coastal cities, are getting drowned. They are getting submerged into water. Some small plateaus are gone forever because they are now submerged into sea. We look into the sea surface rising also, that how much has that taken place. Also, what it does is it changes the composition of the sea water also, and we will look into effects of that, what is the impact of that in terms of the whole ecological system, what is happening, right. So sea extent, as we talked about, that it has kind of going down, and it is happening more on the Arctic side than on the Antarctic side. On the Antarctic side, as we saw into, is that Antarctic side, the temperatures drop has not been that much, as we saw into one of the earlier slides. Look at this, that the temperature drop has not been so much on the Antarctic side. So on Arctic side, the temperature change has been much more. So that's why the ice melting has taken much more place on that side of the globe, the other side of the globe. But look at the million of square kilometer of the changes which has taken place, and it has been a kind of a drastic changes, right. Overall, if you look at it, that in terms of the meter water equivalent, the change has been phenomenal. The cumulative mass balance has led to that has led to so much of water kind of going again into system, and it is leading to the sea rise increase. That is very clearly evident in the whole thing, and that has led to the sea level rising drastically, and sea level has kind of risen 91 millimeters or since 1993, which is a huge number if you look at from that perspective, that lot of places, as I already mentioned, are getting submerged in water, and that is leading to a phenomena where some of the places will be gone forever. It is leading to another thing, that it is leading to a situation where some of the entities or some of the human livelihood which depend upon sea, and they are living in coastal areas, they have to shift, which is leading to social conflict, which is leading to a phenomena where suddenly they have to find new ways of new places to reside, and some of the densely populated area are not finding that places to live. So this is leading to some social conflict also. So this is happening. Some of the areas are permanently now submerged in the water, right. And again, this shaded thing is the uncertainty around the central value of the data, but very clearly the trend is very evident that the sea level is rising, the amount of water which is frozen or which is ice cover is decreasing, sea level is rising, global temperatures are increasing. So these are very clear indications of the climatic condition changing. Another thing which is happening is that the pH value of the sea is decreasing very drastically, because so more and more carbon dioxide is getting kind of absorbed in the sea, which is leading to a change in the chemical composition of the sea water, and because of that the sea is becoming more and more acidic. Like as the pH value goes down, the sea is becoming more and more acidic, and then again these are the variation. I don't need to repeat it again and again, but and as I mentioned earlier, this acidification is not uniform. This acidification is taking place more at few places. This acidification is lesser at few other places, which is leading to a situation where now we have a situation that this acidification is leading to some changes in the life under the water also, and I'll show you some indications of that, right. And along with that, we already have seen this thing that the global temperature is increasing, but what is leading to this, and we will look into this specific gas more and more, that carbon dioxide levels part per million are increasing drastically. And if you look at it, while there has been some natural variations of carbon dioxide historically, which kind of some of the critics, all this global change kind of talks about, that carbon dioxide has never been a stable thing. It has kind of increased because of some natural activities. It has kind of gone back to some natural activities. So there has been a kind of a variation around it, but it has never crossed about 300 ppm level historically, right. So whenever the variation has come, that has remained below 300 ppm. What we are noticing of late is a very clear, very sharp kind of, and look at the slope of all these lines. And if you look at the slope of the current line, this slope is so drastic, so sharp, and so much in sync with the human activity, that it is a very clear indication that this change is not happening because of carbon dioxide change is not happening because of the natural variation which has happened in the past, but it is happening because of some phenomena which is much beyond the natural phenomena which has been occurring in the past. So, and this measurement is primarily done based on the ice core data. So, basically how this measurement is done is that a team of scientists goes into the Arctic or the Antarctic area of the earth, and they kind of take out the big cylinders of ice around the Antarctic and Arctic areas, and from the and since each year some layer is deposited over there, ice layer is deposited. So, looking at the footprint of that layer, they can identify that what was the carbon dioxide in that specific year or specific decade historically. So, because if the temperatures were higher, the density of the ice is different. If the temperatures were lower, the densities of ice was different. So, based on that, and there are some footprinting method which is beyond the scope of this course, beyond the scope of my expertise specifically, those carbon footprinting is done. So, but what we are noticing of late is that this carbon dioxide increase is very strong, and it is even crossing 400 ppm, and we will look into this data more and more. So, it is a very clear indication that the climate change is happening. What we have seen in previous slides, the climate change is happening very drastically, and it is not, and obviously the global temperature warming is because of the carbon dioxide changes, and this carbon dioxide changes cannot be explained by the natural variations anymore. This is a very clear indication that it is happening because of the human activities only. So, overall, if you look at it, carbon dioxide has increased and it has touched up to 430 parts per million. Global temperature has almost gone up by 1.5 degrees centigrade compared to pre-industrial area. Methane, which is another gas, if you remember earlier we talked about methane, the methane has gone up as parts per billion a lot. Arctic sea has ice is decreasing about by 12.2% per decade since 1979, and it is a very drastic dip. The ice extent, ice sheets number of billion metric ton per year is decreasing, huge number, and which is all leading to increasing the sea level, and because of that sea level has increased by almost about 3.6 inches since 1993, which is, as I already talked about these issues, that this is leading to a phenomena where a lot of areas are getting submerged, and we will look into some other aspects of this also, that what is this leading to. This is leading to change in the sea composition, which is leading to some of the species getting threatened, right. And what we also looked into, that the sea is warming because the sea has been the primary source of this energy absorption historically, and this warming of the sea has led to a lot of changes in the sea composition, and the sea overall is a much more hotter body than it used to. And this all, as I said, that since this, if you look at the global level, this temperature increase has been higher at few places, lower at few other places, which is leading to the wind flow patterns, which was in a certain direction earlier. Now those wind flow patterns are changing drastically because of all this change in the temperature, which is the surface temperature changes, sea temperature changes, and so what it is leading to is that it is leading to a lot of disasters, as we kind of looked into earlier, that we looked into this, that this is leading to all these disasters which are happening in all across the globe. It is not related to one geography where these disasters are taking place. So, the evidences are very clear. It is very clearly coming out that it is the atmosphere conditions are changing. All the earth indicators are showing that all the major earth indicators are showing that the things are changing, and this change in the carbon dioxide also gas is showing that, as we already discussed, that carbon dioxide is a long-term earth temperature controller, and this change is so fast that it is very clearly think that it is not because of the natural phenomena. It is happening from some phenomena which are beyond the natural phenomena altogether, right. Like, so when we come next time, we will look into one or two more issues before we kind of move forward into that what is leading to these kind of changes. So, I'll kind of end here today, and just to summarize what we have covered so far is that we have seen that we need an atmosphere on the earth for the earth to survive. Some of these gases has been responsible for these changes and earth temperature stability, but what we are seeing of late is that some of these gases are changing very drastically, specifically carbon dioxide and methane are changing very drastically, and which is leading to a lot of phenomena with respect to global warming, ice melting, with respect to sea level rising, acidification of sea, it is leading to a lot of phenomena, and which is leading to a lot of natural disasters also. So, we will look into 1 or 2 phenomena more when we come back next time, and then we will start looking into that what has led to these kind of changes. Thank you.